Hello and welcome to our second life sciences lesson on the history of the earth. What we're going to do today is we're going to be looking at something called the Cambrian explosion, which actually doesn't have anything to do with bombs exploding. The map for the lesson is part of the map for the section. So if we look at the map for the section, we looked at fossils, we looked at the timeline of the history of the earth, and we're now going to be looking at the Cambrian explosion, which is how the wide variety of earth, or the wide variety of animals on earth, came into being. In the Cambrian explosion, we're going to be looking at a geological timescale, which tells us when different animals existed on Earth and what their fossils looked like. Then we're going to look at how is this timeline, which is 550 million years, so it's quite a long time. How do we divide it up? It's divided up into eras and periods. And then we're going to have a look at the ages of the Earth. Some of the weird and wonderful fossils of animals that did once exist on Earth, even though sometimes when you look at it, it's hard to believe. We start off with revising how does fossilization occur. This is the same picture as in the last lesson. The animal first has to die, soft parts decay, and the skeleton remains, and the skeleton is covered in sediment. Then layer upon layer of sediment is laid down over the skeleton. Groundwater comes through with minerals in it, and the minerals go into the skeleton, and gradually, over millions of years, what was bone turns into stone. Depending on what happens on the surface of the earth, sometimes erosion occurs, and eventually our fossil is exposed so that we can actually see what the fossil looks like, and the paleontologists can get to working out what does it come from, where did it live, things like that. The next thing is, do all animals fossilize? And the answer is no. Anything with a soft body doesn't fossilize very well. However, we do have some fossils of soft-bodied organisms, but that has to happen. The animal has to die, it's got to be buried immediately after death, and it's got to be buried in an environment where there is no oxygen so that it doesn't decay. And that is why fossils of soft-bodied animals are very, very rare, but there are some. So we do have an idea of what some of the soft-bodied organisms looked like. The next one, animals with exoskeletons like your insects, your arthropods, your crabs, things like that, they fossilize very well because they have got a hard exoskeleton. And as we know from the previous lesson, anything hard fossilizes very well. Then, if we start looking at animals with endoskeletons, skeletons inside their body, the bones fossilize, but the soft parts of the body generally don't. So scientists have to look at the bones and then work out from the bones what they think the animal looked like. That is a picture of an actual dinosaur fossil bone. It's quite amazing, isn't it? How large it is compared to the people who are working alongside. So, the people who look at fossils are called paleontologists. And from a fossil bone like this, it's amazing what they can work out. They can work out what an organism looked like, how they moved, and in some cases, what they ate and how they behaved. And all the models of extinct animals that we look at, because of course extinct, they don't exist today. So how do scientists know what they look like? They have worked out, they know from looking at the fossil and working out what the animal must have looked like. So all the pictures you see are derived from fossil evidence. Okay, let's have a look. This is how they work. Okay, they find a fossil of this rather nice dinosaur. Okay, and they put it together. And people who deal with fossils will know how the vertebrae fit together, things like that. So they can put together a skeleton of a dinosaur. Then other experts come in. And they have a look at the skeleton and they know all about muscles. And they will work out to hold up a head with a long neck like that, the animal needs neck muscles that are rather strong. To be able to lift those very, very heavy legs, the animal will need quite strong muscles in its legs. It'll need quite strong muscles in its thighs. So they base the shape of the animal on what they know about animals that exist today and what would be needed to make those bones of the dinosaur move. Then they take and they use their imagination and they take into account the environment in which the animal lived. And that is how they decide what colors to make the animal and what the texture of the animal's skin is like. That is all based on what the paleontologists think, whereas the shape of the animal is based on scientific fact. So it's pretty close to what the animal would have looked like, even though the color of the animal and the texture of its skin could be somewhat different to what the scientists think it is. Now, let's start our look at what happened in the Cambrian explosion with revising what we looked at in a previous lesson to do with the timeline of the Earth. So, let's have a look. This is our timeline, starting with when the Earth was formed 4,600 million years ago. Life started about here, and for all the way up to here, life was very simple, small, microscopic, not very complicated at all, until we got to 550 million years ago, when suddenly in geological time, which is over 10 million years or so, there were huge varieties of different animals, diverse animals, which suddenly appeared in the fossil record. And this rapid expansion of the variety of life was called the Cambrian explosion. And here are some of the organisms that existed, but remember, this is an artist's impression, because anything soft like these tentacles would not have fossilized well. But because they know that these mollusks were similar to octopus, they look at what an octopus looks like and they work out what that animal's head and body would have actually looked like. So we are looking at this huge variety of life called the Cambrian explosion. At the start of the Cambrian explosion, animals were simple. Even though they were multicellular, they didn't have very complex organs inside them. As time went by, the animals became larger, they developed complex tissues inside them, and they became a weird and wonderful array of living things, and we're going to be having a look at some of them later on in this lesson. Now, if we look at this, this is a timeline, and this is 550 million years ago, which is when the Cambrian explosion started. Up till then, all of the animals or all of the organisms were either prokaryotic, unicellular, or they were eukaryotic, unicellular, and sometimes simple multicellular organisms. But during the Cambrian explosion, as you can see, all of these different forms of life, for example, crabs, snails, lizards, starfish, all of those had their origin at the beginning of the Cambrian explosion. Even though what existed in the early Cambrian is slightly different in form to what we see today, the basic groups came into being. Now, this is called a geological timescale. Now, I know it's got a hang of a lot in it, and it's quite a lot to take in. But basically what this sets up is it shows that from 550 million years ago, which is here, it shows the changes in living organisms as time went by. The time before the Cambrian explosion is called the pre-Cambrian era. And that's all those 4,550 million years that we looked at in the previous lesson. And what we're looking at now is what happened after that. And there are three main eras. The Paleozoic era, which is your very primitive animals, your Mesozoic, which is when dinosaurs ruled the earth, and the Cenozoic eras, which is the last 60 or so million years. And if we look, we can see pictures. These pictures show some of the common types of living things which existed at the time. And as you can see from the Cambrian period to now, the living things are very, very different. And what we're going to look at is how life changed as time went by. I don't want you to get your minds all muddled up, so I think we need to take a break.